Hey everybody, my name's Noel, doing another edition of Synergetics and nuclear structure. Today I'm going to teach how to create protons and neutrons with frequency interference patterning. I'm going to begin though by going over some of the things which Bucky had explained in Synergetics. As you'll recall from my other lectures, I based my work on Buckminster Fuller's work as well as others. I learned nuclear structure from Buckminster Fuller's Synergetics before I started studying nuclear physics, and that's why I've come to the deductions that I've come to, and that's what I'm going to teach you today. What exact frequency measures we will need to interfere with one another in order to create the protons, neutrons, and the atomic structure, which Bucky has been talking about. Remember, Bucky says if scientists would like to understand how the universe designed atoms and combinations of them in pure principle, all they need to do is study synergetics. And so I took him at face value as I began studying those works, and then I started studying nuclear physics after that. And I found the identities and the connections so interesting that I began my own deductions. So let's just get on with it then. A little bit of information from Bucky's work. Remember, there's 1,500 pages of this type of stuff, so please refer to him. He talks about what are called the A and the B quantum modules, as well as other modules. A or a B quantum module, and the other modules I'm speaking of, are asymmetric tetrahedron. The A quantum module is derived by fractionating the regular tetrahedron into 24 equal parts. The B quantum module is part of the fractionation process within the octahedron. Now what happens is that you take two of the A quantum modules, which are asymmetric tetrahedrons, and one of the B quantum modules, and you can add them together and they became another sized asymmetric tetrahedron, which happens to fill all space. The same way that cubes fill all space, the same way that the tetrahedron and the octahedron together fill all space. Now, Bucky knows some interesting things about these quantum modules, or asymmetric tetrahedrons, that he was fractionating and discovering the relationship patterns and the behavior patterns of. He noticed, for instance, that quarks act like a mite. Quarks will contain two energy holding quarks and one energy dispersing quark. That is what these quantum modules do. The A quantum modules conserve energy, and the B quantum modules disperse energy. The reason why is because the surface to volume ratio differs. The surface of the A quantum module is 0.995 and it holds a volume of 1. The surface of the B quantum module is 1.207 and it holds the same volume of space with more surface area, more room for energy to leave system. So when you take two A quantum modules and one B quantum module and you create a mite, you can put these mites together into what's called a coupler, which is an asymmetric octahedron. The asymmetric octahedron then is the place on two spheres where they kiss, plus the interstitial space around the spheres. The mites, asymmetric tetrahedrons, can interarrange themselves into many different ways, which replicates the interrangeabilities of the proton and the neutron. Remember, this is all Bucky's work in Synergetics, which I'm going over right now, you guys. So, some other things he did was, he started likening the tetrahedron as a model to aspects of nuclear behavior as well as electromagnetic radiation. See, the tetrahedron's behavior models the behavior of electromagnetic radiation. Bucky noticed that you could take a triangle and you could take it apart, right? And you could turn it into a spiral. Sorry, this one's not working, obviously. This half spiral, one triangle broken open, added to its opposite triangle broken open, added together equals one structured tetrahedron. He's really kind of cool. He talks a lot about interesting things in physics. Pretend that, see these vectors here, these three vectors here, they represent action, reaction, and resultant. Say I'm standing in a boat right here, and I jump woof to this boat right here. Say this is a boat, and this is a boat, and I'm standing in this boat right here, and I jump to this boat woof here. The action is me jumping whoosh. Reaction is this boat's going to spin. Resultant is me landing in this boat, and it's spinning. He then likened the action-reaction resultant phasing of movement with that model to the action-reaction resultant within the Large Hadron Collider as we're busting up and watching the interchangeabilities between the neutron and the proton. In one sense, he's saying the action is the proton, the reaction is the electron, and the resultant is the antineutrino. On the other side, he's saying one of these vectors represents the neutron. As an action, the reaction is the positron, and the resultant is the neutrino. And you put these together, and it's one structure called the tetrahedron. He created other quantum modules also. Out of a complete piece of square paper, perfect square, he was able to fold up quantum modules called the T and E quantum module, and these would fill all space within a tricontahedron. 120 T or E quantum modules create a tricontahedron. Bucky likes to explain that the difference between the T and E quantum module's edge length, which differs by 0.00051, is the difference between energy as matter and as electromagnetic radiation. This is extremely close to the atomic mass unit of the electron. What he likens this model to is a tricontahedron this size, like a bubble, a child's bubble that's blown, and the incoherency of the atomic structure relating as an analogy to the structure of the tricontahedron as matter. When it gets just a little tiny bit bigger, this 0.005 difference becomes electromagnetic radiation and loses energy from the system. When the bubble that the child blows gets to a certain point, the critical proximity and the tensional integrity of the intercoherence of the molecular structure bursts, and the liquid form turns into gaseous molecules, and then reorganize themselves into little liquid particles again, in essence. Bucky's thoughts are very interesting. He teaches about how the tetrahedron, remember the A and the B quantum module, they have the same volume, different surface ratios. Similar happening. The T quantum module has a surface area 0.9989 and holds one full volume of energy. Interesting about the E quantum module is that it has an edge length of a surface area of exactly 1, and its volume that it holds is 1.00155, so it releases energy. So we have quantum modules that hold and conserve energy, quantum modules that release and disperse energy. What I noticed of very extreme value when I was studying this before I started studying quantum mechanics, nuclear physics and whatnot, is that the T divided by the E quantum modules, difference in length is at 1.005. That's the same difference between my quanta scale 0 point and my Penn scale 0 point. And I found that very interesting. Bucky shows in his book about how, I'm going to make sure we're still running here. Great. Let's see if we got this. So, he talks about how the A quantum module, and the B quantum module, and the C quantum module, etc., they all have the same volume, even though they kind of can stretch out to infinity. As the surface area increases and the volume stays the same, the amount of energy dispersing from the system is much greater. You'll notice then also, though, that it turns into a line at great length. I'm going to show you then this other model here, just real briefly, so we can get a little bit better idea of how this equal volume works. Remember what our basic math that we all understand is. The base area times the height times 1/3 is the volume of the tetrahedron. If I were to take this tip and move it this way a little bit, it would still have the same volume, although the isotropicness would change. Isotropic means always and everywhere the same. So the balls would slightly vary their size, and the vectors would slightly vary their size in order to accommodate the movement, right? And as it got farther, they would accommodate more with different sizes of these vectors and the spheres. It would also only have the same volume, though, until it stretched out to it was basically a line. I hope you're following me. Thank you very much. Because now I'm going to move on to the next little section. So this is what Bucky's teaching me, right? I start learning nuclear physics. What does nuclear physics know? Etc., etc. We know a lot, you know. Got books and books and books of it, don't we? We know that universe creates protons when its frequency is approximately 10 to the 23rd cycles per second. And its wavelength is at approximately 10 to the negative 13 centimeters. Its wave's length is really super small. That wavelength is containing 10 to the 23rd number of cycles. That's a huge amount of frequency of interference patterning. On my model, I'll show us once again because I want us to understand. See, this is a 6-frequency tetrahedron. If you're just joining me, please view my other lectures. Frequency is intervaling. Frequency of intervaling pattern. So how many intervals between the closest packed unit radius spheres? This one has 6. See how much dynamic interassociative propensities are occurring with all the different vectors and all the different spheres inside. Imagine then, this is a 6-frequency tetrahedron, and it is approximately 1 foot to the edge length. Its wavelength, see its wave linear edge length, is approximately a foot. Imagine then that we took this and we increased it to 10 to the 23rd power frequency. That's a huge amount of interference patterning in there. And then we shrunk it down to 10 to the negative 13 centimeters in size. Now we have some idea of the total number of interassociative proclivities which exist within the interrangeabilities of vectorial energetic connections and forces which are occurring within the proton, the neutron, and the atoms. With an understanding of how much interference patterning is occurring, and with a deductive reasoning, we're starting to get close to where mankind's going to be able to create protons and neutrons, because I now have the exact frequency measures that these are occurring, as I went over in my other lectures. I'm going to go over again right now. So we know that the amplitude at which a photon couples with an electron is at 0.0854, which is 1 divided by the second root of 137.03, right? Our fine structure constant. We know that we get a lot of stuff, you know. Protons MeV at the rest mass, the electrons MeV at the mass. We have fine structure constants, the atomic mass unit of the electron, Planck's constant. We know a lot. We know that energy is ratioing itself in accord with the frequency multiplied by Planck's constant. With that in mind, we'll try and understand a little bit about the photon's particle and wave duality. Einstein got a Nobel Prize, I believe it was in '32, for the hypothesis of the photon being a particle, saying light travels in particles. Niels Bohr, Kramer, and Slater, they refuted this and claimed not so. They said that Planck's constant was a coupling constant, and when electromagnetic radiation coupled with matter, it acted like a particle. I'm not trying to get necessarily into this debate, but it's very interesting because remember that Tesla, he said that mankind should think in terms of energy and frequency and vibration. We think in terms of particles. We keep trying to find this particle, this building block in the universe. What we're not understanding is how energy vectors structure themselves and self-stabilize themselves in inter-triangulated patterns, as I've shown in my other videos and the other models, and how these self-stabilized energetic triangular patterns then create polyhedrons and bigger polyhedrons and continuums of them. A man named Jeff Harries, he put something on the internet called the phony photons. Very interesting experimentation. It's available at the phony-photon.com. The phony photon. Jeff Harries' website then, this is what he says. He says, see, I did many ingenious experiments, interference, refraction, nonlinearity, with laser light of all intensities, using photographic films, then a photomultiplier tube as detector, and they all supported the hypothesis that light was a wave. See the interference experiments. I made a calculation showing photons, if they existed, were far too we're far too far apart, even in a strong laser beam, to ever interact. See the calculation of photon density. I also showed that there is normally no photon bunching, so there are no photons. If I assume that the free electrons in a sodium crystal behave like the free electrons in the carbon load of an radio frequency dipole in the presence of electromagnetic radiation, I could explain the photoelectric effect using conventional radio frequency antenna theory, and more completely than Einstein. See the photoelectric effect. The Compton effect using X-rays, and first seen as much more difficult target, felt surprisingly easy. He explains the Compton effect. Pair production is a strange phenomenon showing how very high energy electromagnetic radiation reacts with matter. Its conventional explanation requires the electromagnetic radiation to be quantized into photons, particles, and also requires the invention of a new particle, the positron. My classical explanation removes at least the need for photons. You should view this work, guys, it's really great. Now, once the keystone of the photon was dislodged, the whole structure of quantum mechanics came tumbling down, and an enormous number of scientific papers and books are revealed as pseudoscience. Remember a couple things, you guys. Feynman, towards the end of his life, he says, nobody really understands quantum mechanics. Einstein, at the end of his life, he was interviewed, and the interviewer said something to the effect, you know, it's great that because of your work, now so many people can understand what a quantum is. And Einstein replied, I only wish that I could understand what a quantum is. And so we still have this big confusion because we're learning how to destroy things and blow them up. We've learned how to put uranium and plutonium together and blow them up. We know how to blow things up in Large Hadron Colliders, but we don't know how to construct them. If physicists ever like to understand how universe designed atoms and combinations of them in pure principle, all he needs to do is study synergetics, and what I'm teaching today and in my other lectures. So remember, Tesla says that we should think more in terms of energy, frequency, and vibration. Remember in my other lectures I told you I found the 0 points or frequency measures were creating structures. Which structures had total numbers of energetic vectorial interconnections, which were reducible as a whole family of forces into whole rational unit measures of the proton, the neutron, the electron, including Planck's constant and the fine structure constant. Please view my other videos. In this video then, I'm explaining exactly how we can replicate the process that universe uses in order to create protons, neutrons, and atomic structure. We know that our first 0 point multiplied by our first wave embracement field is the total number of energetic vectorial interconnections in the 136 frequency tetrahedron. We also know that in the Penn scale 0 points, it's 0 point times its wave embracement field. Same with the Quantus 0 point and wave embracement field. These are the total number of energetic vectors which are creating structure and stabilizing tetrahedral structures. So what we need to do is, similar to the Large Hadron Collider, but opposite, we need to create a machine of this type which will allow us to introduce these exact frequency measures. We know the amplitude, right? And the amplitude shows up from my Quantus 0 point, 0.0854, is 1 divided by the 4th root of my first Quantus scale 0 point, divided by the angular variation within a circle, 360 degrees. Notice I don't use pi, imaginary numbers, or any other irrational or irresolvable constants. So we know that the protons created at approximately 10 to the 23rd cycles per second. What we need to do then is all we need to do is take my 0 points, because they continue ad infinitum, and when mankind can create exact frequencies of electromagnetic radiation and send these exact measures of frequency and interharmonize them, we're going to start creating structures like protons and neutrons in atomic structure. We'll experiment, because you can double this or halve it or double it and double it and double it again, as we're seeing here. But approximately the 66th data point, or 9384 times 2 to the 65th power, is our 10 to the 23rd power of cycles. This is the exact, remember we have the exact 23-digit number. I've got all 23 of those, and we've got that entire number on each of these. We have exact frequency measures, which we can now combine in order to create the structure. And combining these will not only create the structure, but we'll be harnessing, or we'll be creating energy which we can then harness. Unlimited supplies of energy and unlimited supplies of protons and neutrons and atomic structure can be created off planet Earth, in biospheres on other planets, for instance, or on the moons of the other planets. We'll recall then that my quanta zero point divided by my Penn zero point is always going to ratio the electron's atomic mass unit, 0.000545. Remember then, all these numbers break up into Planck's constant, the fine structure constant, the masses of the proton, the neutron, and the electron, and whole rational units using only basic mathematics. When you see when we get up these high frequency points, I still have the same ratio between Penn scale, my 0 point, and my quanta scale 0 point. Remember when you take 0.000545 and you multiply it by the proton's MeV, 938.4? You get 0.511, which is the MeV of the electron. Remember how all these numbers ratio in whole rational units to each other. 137 to the second power minus 1 divided by 20, which is the volume in the vector equilibrium, is equal to 938.4. Ladies and gentlemen, we will need to experiment with these things. I'm giving you the basic information. I will be doing some more lectures later. I appreciate your time, and I'm sorry if I've left anything out. Join me again. Thanks.